Welcome. Today we're going to talk about how to work with an ellipse centered at 0, 0. Now, when you're working with an ellipse, there are many things you have to do. Some books like to tell you that the A and the B have to switch which one they're under. I just find it easier to just say the A squared is always under the X, the B squared is always under the Y, and which one is which depends, whether you're talking about a horizontal major axis or a vertical major axis. You're talking about which one is the bigger denominator instead of which letter is which. It's much simpler. So this is the equation. I'm not sure why it's funky like that. It's the way the program did it. But this is the equation in standard form for a horizontal major axis. And with a vertical major axis, you have it over here. A squared is greater than B squared for a horizontal, and B squared is greater than A squared for a vertical. In other words, the denominator of X is bigger for horizontal, and the denominator for Y is bigger for a vertical. Major vertices are plus or minus A, comma 0, and minor vertices are 0, comma plus or minus B in a horizontal major axis. And the reverse, major vertices are 0, comma plus or minus B, and minor vertices are at plus or minus A, comma 0. You find the F for the foci by taking the square root of the big denominator minus the small denominator. Remember, they're already squared in there. So the foci here is going to be in the x-coordinate spot, the plus or minus F, comma 0. And the foci here is going to be in the y-coordinate spot, 0, comma plus or minus F. A horizontal ellipse looks like this. The major vertice, the minor vertice. And really, the vertice is nothing more than the place where the direction of the graph changes. So this graph is coming along like this, and it's curving, and then it starts to change in the direction it's curving. It's going down, now it's going to the left, I should say, now it's going to the right. It's going up, now it's going down. That type of change. And of course, in a vertical ellipse, these are the major vertices, and these are the minor vertices. I should have done it in a different color over here. Major vertices, minor vertices. And of course, it's whichever is stretched further. The one that's stretched like this is along the horizontal, so those are the major, and the lesser stretched is the minor, and vice versa. So if we're looking at an equation, we can tell that this is the kind of equation that has a vertical. This is a vertical or a major axis on the horizontal, vertical, not a horizontal, because the bigger denominator is under the y squared. Now, does it really matter whether it's x squared then y squared? No. You could have y squared then x squared, as long as you know which one's which. All right, so if that is the case, the major axis, of course, is going to be the y-axis because it is vertical. The major vertices are going to be 0, comma, plus or minus. You could write it plus or minus, or you could write them as separate ones. 9. So at 0, positive 9, and 0, negative 9 are your two vertices. The minor vertices are going to be at, notice the y is the bigger denominator, and it's in the y for the major. So the minor, now by the way, I didn't really mention this, b squared is 81, so b is 9. So a squared is 64, a is going to be 8. There are your minor vertices. The foci, f value is the major vertice minus the big one, sorry, the big denominator, not vertice, big denominator minus the small denominator. So that gives you the square root of 17 for f. So the foci is going to be found by, it's in the same coordinate spot as the major vertice. So it's 0, comma, plus or minus the square root of 17. Now, what is the foci? The foci is the point, let's go back to the diagram. It's the point here and here, where if you were to draw any point on the line, let's use a different color, any point on the line, the distance from here to here and here, that distance is the same no matter where you pick on the graph. If you did here, if you add up this distance plus this distance, it's the same as the other line. So when you add 1 and 2, it's equal to 3 and 4. If you add up those sides, they are equal. 1 plus 2 equals 3 plus 4. And that's what the foci is. And you can actually take a piece of string of that length and push it, and you can draw out the full shape. So that's what part of what the foci does. So there is all the information that we'll be asking. Here's another example, different form. If I start with this one, that's not the form I want. Remember, the form you want has to be equal to 1. So I'm going to divide everything by 400, and that gives me x squared over plus y squared over equals 1. And it turns out that 16 and 25 both go into 400 nicely. Coincidentally, it's 25 and 16. It doesn't have to be that, but they're just swapping. This is going to be a horizontal ellipse. And it's going to have a major axis of the x-axis. Major vertices are going to be at, notice it's the bigger one is under the x, so it's in the x coordinate spot, plus or minus 5, 5, comma 0. The minor vertices are going to be 0, comma, plus or minus 4, square root of 16, 4. And the f is the square root of 25, the big denominator minus the small denominator. Doesn't matter which one is the big, which one it's under, it's always big minus small. So f is going to be the square root of 9, which is the number 3. So the foci is going to be at plus or minus 3, comma 0. And there is your major facts that you need from this one. All right. Now, what if they give you the vertices? They don't tell you which one's the major and the minor. Well, it's going to be kind of obvious that this has to be the major and this is the minor because of the size of the numbers, 11 and 4. So since that's the major, x squared plus y squared equals 1, and they're over numbers, I have to, this is the a value, so I'm going to square it, 121. This is the b value. When I square it, I get 16. And there's your equation. Let's take a look at another option. What if they give you a vertex and the foci? Well, how do I know if that vertex is the major or minor vertex? That's actually easy to know because the foci is always the same position as the major vertex. So this must be the major. And that's the foci. So we know it's x squared plus y squared equals 1, and they're over something. The 9 squared is 81. That much we know. We need to figure out what a is. Well, we know that f is 4 square root of 2. Okay. How do I find f? It's the big denominator. We know that's the major one, minus something to equal that. Well, if I want to make this all inside the square root so it's easier to work with, we have to, remember, to pull it out, you had to pull out 4 times 4 to get the 4 on the outside. So this is really 4 times 4 times the 2 that's in there, or 32. So we have to figure out what do I have to subtract from 81 to get 32. Well, 81 minus 49, turns out, is equal to 32. So this has to be 49. 81 minus 49 is 32. So therefore, this is 49. And there is how you will find your value for a squared. The other way you can think of it is you could square this, and that would tell you what would have to be inside. Either way of approaching it. And that's it for today. Hopefully that was clear. Have a good day.